Hello, now we are going to talk about the partial functions. These partial functions are inside of functool modules. So you can import these partial functions from the functool, like over here. Now, let's understand how the partial function works. So here, we have defined the function called myfunc. We have the three parameter over here, a, b, and c. And now, this function just print the three parameters, right? So with the help of partial function, so here the way we are using partial function is we are using partial. Then inside this partial function, the first we are passing the function name, and the second we are passing the attribute value. Which attribute value? You can even say that a equal to 10, or you can even leave that. So it will take the default value for a. So here, what we're trying to do is we are setting the attribute value, or we are defaulting the attribute value in these partial functions, right? So next time when you call this, you do have to pass this the value for b and c only. And again, here you will have to call the f function then. So let's run this. Now let's try to call f of 20 and 30. Now this 20 and 30 is for b and the c now. This 10 hasn't already been defined as a default for this f function, right? So when you run this, you will see that the 10 is over here at the place of a, right? You could have even done this using the another function or the lambda function as well. For example, consider that here we have defined the partial func, which takes b and the c. Then it is returning my func, which was this func, this function. And now the default value of this function is already given, 10. And then this b and c we are passing from the argument, right? We can even do this. Again, if you run the partial function, here you will get 10, 20, and 30. We are achieving the same result. Or you can even use the lambda function over here. So this lambda function will take b and the c value and then will return a function itself. So it will return, so it is a calling a function, right? Now again, if we call this fn, we'll get 10, 20, and 30, right? But again, if you are using the partial function, this partial function, it is much more flexible with the parameter or the type of parameter. You do not have to define these functions, this type of functionality, right? Again, consider these example. We have this my function, and then we have these two parameter. We have this unspecified argument. Here we have this unspecified keyword. We have these two keyword value, k1 and k2, right? So we have this lot more parameter over here. Now let's try to run this. So if you're using the partial function, here we're passing my func, then the 10 value will be automatically defined for a. And then we are defining for k1 value, which is a over here, right? Now, when you call the f function, you just need to pass the other value. That's it. So it's very simple, right? You can achieve the same thing by defining the function, but again, this definition is not very much flexible. It's not very much easy. It's not very much handy. So you should use the partial function over here, right? Again, let's use the partial function. Consider that we have defined the function called power. It takes 2 base on the exponent and return base raised to exponent, right? Let's run this. Now when you call the power, 2 to the power 3, we are getting 8. Now let's define the partial function over here. In the partial function, we are giving the function name, right? And then we are defining the exponent default value as 2, right? So this exponent value is 2. That means whatever the value will pass in the base, it will give you the square. And here we have defined the square function in this way, right? So if we'll take the square of 4, we'll get this. You can even redefine. So here we are defining the cube function, cube of 2. You can even call it by changing the base, right? So here we're saying that cube base equal to 3. So here we are changing the base value. So you can even call this by defining which value you are passing, right? Now we can use a variable instead of the literal, like over here. Here we have this function, it takes 3 argument, and then we are saying a as 10, and then we are using a variable over here. Again, it is working, but let's change the variable value, which is 100. And now let's try to run this. We are still getting 10 over here. That means a has been fixed. That means once you have created a parcel, that value has been fixed, right? Now if we use the mutable object, then things are different over here. Let's see that here we have this a variable. Here this a was non-mutable because it was just the, I'll say that, integer, right? So integer is the mutable object. But if you have the mutable object, like over here, the list is the mutable object, right? And then we are using a partial function over here instead of a. So instead of entire list, we are passing a over here. Now let's try to call this. So a is getting as a list. Now if you change this mutable object, so here we are adding this element 30 and then we are running this. So now we are getting the changed element. So this will work if you are working with the mutable object. Here is one use case of that. Consider an example. Suppose we have a point and then we want to sort them based on the distance of point from some fixed point. So we have the list of point or the tuple of point, right? And then we want to sort all these points based on one fixed point, based on the distance between all the point and the one fixed point, right? So how this will work? Consider that this is the origin we are taking, which is 0 0. So we want to take the distance between this object to the origin, distance between this object to the origin, and then so on. And based on this distance, we have to sort them, right? So here we have created a list. Now here we are using the lambda function to create a distance function. Let's create it. Now we can check that. We can calculate the distance between 2 points, right? Again, this is a Euclidean distance we have created. Now let's try to use the sorted function. Here we have used the sorted. We have passed this sequence object L. Then as a key argument, we are passing function like it takes x, right? So here we have this x, and then we are taking distance to dist2, this function we are taking, and then we are passing 0 0 over here, and then we are passing x over here. So this is, we are using a lambda function to create or to sort the all the value of x with these zero value, right? So this lambda function is returning distance function output, right? So we have got this output. Now let's try to convert this to a partial function. So here in the key we have passed the partial function, right? And then in the partial function, now in this distance function, this is, we are setting these values in fixed. So here we have set that dist2, and then these value has been fixed. So this first element, x element, has been fixed, right? And now we can use this sorted function. If I do so, we'll get all the elements sorted based on the distance from this origin value. So this is the application and the use case of the partial functions, right? It's very handy if you have to set the default value of the parameter and use as a different functions. Or if you have the lots of parameter value to pass, then you can pass some of the parameter value, right, to make it simpler, right? And thank you.